to add complex numbers. You want to add the real parts. And add the imaginary parts. In other words, just add the like terms. So if we've got 3 minus 5i, and we want to add 7 plus 2i, you add the 3 and the 7, and you add the negative 5i and the positive 2i, and that's it. That's all you have to do. Just like if it was an x. To subtract, you want to distribute the negative and combine or add. So if we wanted to take 3 minus 5i and subtract 7 plus 2i, there's no negative in front of these parentheses, so they're just there for looks. Here we've got a negative, so we're going to have to carry that through. No different than what we'd have if it was an x, so minus 7 and minus 2i. So if this was a negative 2i, minus a negative would change it to a plus. So 3 minus 7 is going to be a negative 4. A negative 5i and a negative 2i would be a negative 7i. All you have to do. Now multiplying is a little trickier. If we had, say, 3 times 5i, that's just going to be 15i. No problem. If we had 3i times 5i, that would be 3 times I times 5 times I would be a 15, 3 times 5. I times I is I squared. But remember that since I is the square root of negative 1, then I squared is going to be the square root of negative 1 squared. When you square a square root, they cancel out. And so I squared is the only thing, I is the only thing you can square and get a negative answer. So 15i squared is the same thing as 15 times negative 1, which will change that to a negative 15. Now let's look at that again. Anytime you have an I squared, you're multiplying by negative 1, which changes the sign. If we had a negative 3i times 5i, we would have a negative 15i squared, which would be a negative 15 times a negative 1, which will turn out to be a positive 15. Anytime you have an I squared, it just changes the sign because it's just a negative 1. Let's say we had negative 7i times 2 plus 4i. Distribute it. Negative 14i and a negative 28i squared. Negative 28i squared is going to turn out to be a positive 28. And they always want you to write this in the form A plus BI, with the real part first and the imaginary part second. So they're going to want this answer to be written as 28 minus 14i. Some people care about it more than others. Some computer programs are programmed to care about it more than others. If the instructions say to write it in the form A plus BI, or to write it as a complex number, then it may actually count it wrong if you do not write it like this. Let's look at something like 2 minus 7i times 5 plus 6i. What do you think? What do you always do when you have 2 terms times 2 terms? FOIL it out, right? So 2 times 5, our first will be 2 times 5 is 10. Our outer, we got first, outer, inner, and last is where FOIL comes from. So here's our first, 2 times 5. Our outer are the 2 and the positive 6i, which would be a positive 12i. Our inner terms will give us a negative 35i. And the last is going to be a negative 42i squared. For some reason, people that do fine when this is an x have a tendency to forget that this last term has to be I squared. So be careful about that. You're never going to FOIL out and get one kind of one term and 3 of another. It just won't ever happen. So we've got 10. Now, plus 12i and a minus 35i would be negative 23i. A negative 42i squared is going to be a positive 42. To write it as A plus BI, 10 and 42 give us 52. So it's going to be 52 minus 23i. Notice that when you multiply 2 complex numbers, you get a complex number. So this is closed with respect to multiplication. What about division? In division, we don't actually write it out. We don't actually divide. You don't want to write something like, let's say we've got 2 over 3i. To write it as a complex number, you can't have the I in the denominator. You're not allowed to leave any I's in the denominator. So this is how you get them out. Now in this case, because there's only one term down here, we can actually get the I out of the denominator by multiplying top and bottom of this by I over I. It's going to become a 2i in the top, but it'll become a 3i squared in the bottom, so that we've got 2i over negative 3. And we can write that as a negative 2/3 I. As long as the I is in the top, you can slide it off to the side, but you cannot do that when it's in the bottom. As you will see, this didn't come out as 2/3 times I. If you have more than one term in the denominator, it gets quite a bit trickier. If we had, say, 3 minus 2I divided by 5 plus 4I. Now I can't multiply this by I over I because it'll make this a negative 4, but it'll change this to a 5I. So that is not going to get the I out of the denominator if you have more than one term. So the trick is that you have to multiply the denominator times the conjugate of the denominator. Change the sign. Let me show you what happens when we do that. If I FOIL out the denominator here, I'm going to get 25 minus 20I plus 20I minus 16I squared. The negative 20I and the positive 20I cancel because we're multiplying conjugates. 25, this becomes a plus 16, and 25 and 16 add up to 41. So I got the I out of the bottom by multiplying by the conjugate. That actually squares both terms. Anytime you multiply A plus B times A minus B, you end up with A squared minus B squared. So when you multiply by the conjugate, it'll automatically square the first term to get the 25. It'll square the second term. Well, it'll be minus. You'll have the first term squared minus the second term squared, which will be a minus 16I squared. In the case of I squared, that becomes a plus 16. 25 and 16 add up to 41. Okay, the top doesn't work so well because these are not conjugates, not even close. So we got 15 minus 12I minus 10I. Negative times a negative is plus 8I squared. So 15, this is going to be a minus 22I. Let me hold off for a second before I put this 15. This and this are going to give us a negative 22I. This is going to be 15 minus 8 plus 8I squared would be minus 8. And 15 minus 8 is 7. Now to write this in the form A plus BI, we can separate this out into two fractions. So we've got 7 over 41 minus 22 over 41I. And that's your final answer written in the form of a complex number.